Hi guys, welcome to the first of many videos walking you through the Algebra 2 curriculum at an honors pace. So this is an honors Algebra 2 video set right here, and this is our very first lesson. To start things off, what I'll generally do on one of my lessons is I'll put a do now on the top of the lesson, and this will be something either reviewing stuff you already know or kind of planting a seed that we springboard into the lesson with. So I always will want you to try out the do now for yourself and pause my video while you try these, see if you remember how to solve some different stuff from algebra class, and then I'll talk about them now. So try them yourself before you listen on. The first problem here says to simplify, and when you simplify, this is called an expression because there's no equal sign in it. Simplifying means combining like terms. So the first thing I need to do is I need to distribute that negative 6x so there are no more parentheses. Negative 6x times 2 is a negative 12x. Negative 6x times negative 4x is a positive 24. And then x times x is going to make x squared for that term. So you distribute the negative 6x to both parts of the parenthesis, but not over here. This guy just carries down. And after you've distributed, you're going to combine like terms. So this is my only x squared term. And usually when you write your answers, you should write them with the biggest exponent first. So I'm going to do 24x squared. And then I can combine a negative 12 and a positive 1x. Negative 12 plus 1 makes a negative 11. And you don't change the variable when you combine like terms. So you get negative 11x. This is a simplified answer. When a problem says to simplify, they just want you to clean up the problem and combine your like terms. Moving on to the second problem right here. Now I don't have an expression, but I have an equation because of this equal sign here. When it says to solve, they want me to get x by itself. Well, that means distributing the 3 first. I'm going to get 15x minus 6, and over here I have a 12x. If I'm going to solve for x, I got to get x by itself, so I'm going to choose, you could subtract this 15x over here to the right, or you can subtract your 12x to the left. I'm going to choose to subtract the 12x. When I pick problems in these videos and on these do nows, I sometimes pick things that kids mess up on just so I can talk about them with you. 15x minus 12x is a 3x for this part. This negative 6 is on the left side of the equal sign, so it still stays right here. I'll have kids try to put this negative 6 over here now, but that's not the case. On the right side, I don't have anything left, so there's really a 0 right there. And once you do that, it's pretty easy to solve. You're going to get 3x equals 6, divide by 3, and your answer is going to be a 2. So that is our second problem here. And on our third do now question, I'm going to do a similar sort of process here. Sometimes people will think they need to multiply this 4 into the parenthesis, but 4 is not being multiplied. It's just sitting there. So what I'm actually going to do is bring down the 4, and I need to distribute a positive 1, because there's a plus and like a little 1 right there. So that's going to make this say plus 3x and plus 7. And then on the other side, I'm going to get 18 plus 3x. So my job now is to solve. I'm going to start by combining like terms on the same side. I can put the 4 and the 7 together. And then there's really nothing I can do on the right side, but I'm at least going to reorder it. Not that I have to. So x is on the same side, or x goes first. My next step is to get the x's over to one side. And when I subtract 3x on both sides here, this is going to cancel. But actually, this is going to cancel as well. So now my problem just says 11 equals 18. 11 equals 18 doesn't make any sense. That's obviously not true. And I don't have an x anymore, so I can't solve it. If your variables cancel and you get something that doesn't make sense, it is a no solution for your answer. There is no solution. The symbol for no solution is like a 0 with a line through it like this. Now let's say I did the same sort of problem, but I got like 11 equals 11. This is actually a true statement. And sometimes people will want to say like all solutions or something like that. The fancy math way for this is called all real numbers. And the symbol for all real numbers is like an R, capital R, but it has 2 lines instead of just 1. So if your variables cancel and it doesn't make sense, like here, no solution. If they cancel but it does make sense, you say all real numbers. And that's the end of our do now. So let's go ahead and jump into new content here. Now you guys have probably been looking at this guy right here like, wow, that is an impressive piece of artwork on your page. It just looks so good. What is it for? Why are you showing me this crazy awesome looking machine? Well, it's actually going to illustrate some vocabulary I have below. And I do want you to draw this guy or something maybe not as nice, but draw something like this in your own notebooks. The idea of math is that you could have problems with one variable like this, but a lot of upper level math is done on problems with two or more variables. So when you talk about problems with more than one variable in them, the general catch-all word for that is called a relation. So a relation is going to be an equation with two or more variables. Basically, what a relation does is it takes you from an input that you start with to an output. You plug one thing in or you do one thing and you get out another. So I have my little machine here to illustrate this. Let's say I have this machine and it's like a little wood chipper type deal right here. You put a number in, something happens inside the machine, and another number comes out. Let's say I put in, for my inputs, the number 2. Well, the machine does some crazy mysterious math right here, and for my output on this one, I end up getting the number 5. There's a lot of things that could happen inside this machine to get me from 2 to 5. Maybe it added 3 to the number. Maybe it multiplied by 4 and subtracted 3. Maybe it squared the number and added 1. That possibilities are endless. So we would really just need to see more data to figure out what's going on. Let's say next I plugged in a 4 and it did some magic right here, and after it plugged in a 4 I got out an 11. And then I do one more just because if I plug in a 10 it got me a 29. So something crazy is happening in that machine. You could try to figure it out because there is a pattern to this right here, but that's not what I'm interested in right now. What I want to talk about is what would happen if I put in a 3 or something like that. So this orange part does not follow the same pattern as the blue, but I'm just illustrating something here. Let's say if I put a 3 in this machine, it actually gives me 2 separate answers. I get out a 10, and I also get out like a 14. This would be really, really weird. The blue makes sense because I put in one number, I get out one number. Put in one number, get out one number, just like that. But this orange right here is a problem. If you put in one number, you shouldn't be able to get 2 numbers out. It just doesn't make sense logically. So what we do is we call this sort of orange thing a violation. It doesn't actually work like we want it to in most math problems. I'm skipping these for 1 second here, and I'm going to jump down to the bottom. A function is a relation where each input only has one output. Only has one, I'm going to use the word unique, outputs. Each input only has one output. So this right here in orange would not be a function. I have one input that has 2 outputs. That's weird. You can't put one thing in a machine and get 2 out. That shouldn't work out. So we don't like things in math like this that aren't functions. Function is a good thing. It means, oh, each input only has one output. So this is what we want to have, not what we see up here. 2 more vocabulary terms, domain and range. They have to do with what's going on with my machine right here. All the numbers you can plug into a problem are called the domain. So domain is a list of all possible input values. And the variable we use for inputs is x most frequently. So it's a list of all your x's. When you make a list in math, you use like a little squiggly bracket here. Some kids can't draw this, just do a zigzag if you can't write one of these. So this means lists. And then what you do for your domain is you just list out all the numbers that we use from least to greatest. So you just organize them like that. This is my domain for this problem. Range is a list of all possible y values or output values. All possible output values. And that's our y. So on my problem here, my range would be the numbers 5, 10, 11, 14, and 29. Just put them from least to greatest. That's vocabulary right here. This domain and range we will talk about all year long. Every time we learn about a new kind of equation and graph, I'll be asking you about domain and range. dr is alphabetical, x, y is alphabetical, so it should help you keep straight which is which. Now, to close out this video, I have two example problems here of different kinds of relations, and I ask you for a few things about them. This guy right here is called a mapping diagram. It's just a different way of writing. Instead of having a sweet machine like mine, it's just using bubbles instead. That's my input, that's my output. Domain is going to be the x's that my problem uses, but anytime you write them down, write them from least to greatest. So -9, 1, and 4 is the domain of this problem. The range on this problem is going to be the different y's you can use, again, from least to greatest. And when you write out domain and range, don't write repeats. So don't write the repeats when you do this. You only have to write the number 2.3 once for your range. Is it a function? If I think about this like points, it'd be -9, 2.3. It'd be 4, 2.3, and it'd be 1, -7. All of your inputs only have one output. A y repeats, but I don't care about that. The rule for function is that x can't repeat. Yes, each x is used only once. If it wouldn't be a function, there'd be a second arrow coming off of one of these x's over here. So let's close out this first video here with this last problem. I'm going to go ahead and write down the coordered pairs for the coordinates. This guy is -1x, +1y. This guy is 0, 3. Then we have 4, 1, and we have 4, -2. Once you write them out, it's pretty easy to do domain and range. Domain is -1, 0, and 4. I'm not going to write the 4 twice. You just write the numbers once. These are the x's I can use. Range is the y's. It would go -2 for the smallest, then 1, then 3. And this guy is not going to be a function because this x right here repeats. I use the x of 4 twice. X equals 4 repeats, so it is not a function.